Hello everyone. Let's start with our today's session, which is all about prevention of gear tooth failures. These are how to ensure proper meshing of gears, checking backlash, lubrication of gear systems, oil foaming, oil condition, and breather. The most important aspect of gear drive is that the teeth mesh in the correct way. This can only be achieved if the following conditions are fulfilled. First, the center distance of shafts are at correct position. Second, the backlash must have the proper value. Third, equally face width of gears must be in line. Fourth, the modules of meshing gears are to be equal. The correct meshing of spur and helical gear is checked by applying blue paste or red oxide on the tooth flank of driving gear and giving a several rotation. There will be contact image on the face of driven gear. If the contact image is normal as shown in the sketch, then the mesh is proper. For correct mesh, blue mark will occupy 70 to 80% of tooth face. For worm and worm wheel, blue paste is applied on the worm thread and contact image observed on the face of worm wheel. Correct contact image should be as shown in the sketch. The two mating gear must have some space in which they may move in relation to each other, and also oil film may form to prevent the metal to metal contact. The play must exist between teeth is called backlash. The value of backlash depends on accuracy of gear, center distance, module of teeth. The backlash between two mating gear can be checked by filler gauge, lead wire, and measuring gauge or DTI. The backlash can be measured directly by inserting filler gauge at the contact point of both mating gear teeth on pitch circle. Lead wire is placed on the tooth flank of driving gear as shown in the sketch and rotated till it passes over the mating gear teeth. The lead wire will be flattened. The thickness of flattened lead wire is measured. This gives the value of backlash. Pinion is locked. Pointer of measuring gauge or DTI is placed on the tooth flank of big gear, perpendicular to tooth flank with preload. Bigger gear is turned to and fro. The deflection in gauge gives the amount of backlash. It is to be noted that the amount of backlash must be proper. In case of less backlash, there will be hard mesh, jam running, more heat generation, and tooth may break. In case of more backlash, there will be poor mesh, poor noise, impact load on teeth. Note, the amount of backlash must be proper. Less backlash has hard mesh, jam running, more heat generation and tooth may break. More backlash has poor mesh, more noise, impact load on teeth. Lubrication in gearboxes has two following purposes: to lubricate moving parts to reduce friction and to carry away heat from meshing points. The selection of type of lubrication system depends upon types of gear and peripheral speed. There are two methods of lubrications used in gears: splashed lubrication systems and forced lubrication system. Splashed lubrication system, in that a lubrication fill in gear housing into which teeth of every pair one member are immersed. It is economical, simple in design and reliable. Its cooling effect is sufficient for most application and can be improved by means of special housing designs, auxiliary units like cooling fan or water cooling lines. Whereas with in splashed lubrication system, it is important that a certain oil level is retained at all times to ensure reliable operation. Lack of proper maintenance of oil level will create problems as under. When oil level is too low, it can lead to starvation of lubrication, inadequate heat dissipation, and increased wear. Whereas if oil level is too high, it can lead to increase in churning losses, which can result in high working temperature of gearbox dissipation. Also, replacement or change of oil period gets reduced. Forced lubrication system is employed to enhance thermal rating of the gear unit when gear unit is operating at very low speed, when peripheral velocity of gear internals is more than 15 meter per second, when gear units are equipped with plain bearing like white metal or journal bush bearing in case of high speed gear unit, and for industrial applications generally operates with feed pressure in order of 1.5 kilograms per square centimeter to 2 kilograms per square centimeter. The graph here shows a forced lubrication system for a gearbox with bearings. The system has 3 continuous steps of operation. Oil from the gearbox is collected and sent to the oil reservoir. The oil pump takes suction from the reservoir and the pump discharges oil through an oil cooler and back to the gearbox. Also notice the oil filter shown in this figure. When needed, a pump takes the oil from the reservoir, cleans it in the filter and then returns it to the reservoir. Here we have shown the force feed lubrication system of gearbox. It is important to identify the proper flow pattern of lubrication should be after cleaning the nozzle. For oil level or spray, we have shown the table in which pitch line velocity is mentioned, method of application is mentioned and remarks. Please go through it. Now, before we discuss the concept of oil foaming and how it affects the gearbox, let's understand what foam is. Foam is a collection of small bubbles of air that accumulate on or near the surface of the fluid. In severe cases, the foam can leak out of the machine through breathers, sight glasses, and dipsticks. Foam is an efficient thermal insulator, so the temperature of the oil can become difficult to control. General causes of formation of foam are as follows: mixing of gear oil with oil of an other brand, contamination of gear oil by bearing grease, dust and water, and wrong filling quantity. To prevent foaming, the following factors must be taken into account: method of filling, preventive proactive maintenance programs, tank design and lubrication selection. The filling of the tanks is critical. It is advisable to add the oil with a hose pushed right into the tank to avoid introducing air. When a new tank is filled, air can be trapped in the dead zones, so purging should be carried out. The correct procedure consists in emptying the tank with a vacuum pump and maintaining the vacuum while the tank is filled. The recommended preventive maintenance tasks are checking gaskets and seals, visual inspections, checking oil levels and filters. In addition, it is advisable to monitor cleanliness, eliminate moisture, filter the oil well, and remove contaminants. If despite following good maintenance practices the foam persists, you must locate the point at which the air is entering and prevent this from occurring. Tank design is usually the most important factor contributing to the foaming of oil. Among the main problems are the following: the return line is above the oil level, the tank is small, the tank should have capacity of between 5 to 10 times the flow rate of the pump, or in splashed lubricated systems 0.4 liter per kilowatt is recommended. The oil level in the tank is low, the moving parts introduce air into the system. The oil level in the tank is low, so the moving parts introduce air into the system. In lubrication selection, the optimal oil has to be highly resistant to the entry of air and should not retain bubbles after these form. The oils that best comply with this model are synthetic fluids and hydrocracked oils. In general, when the foam problem is found in a gearbox in splashed lubrication system, then following attempts are to be taken: drain the oil and flushing the gearbox, Filter to be checked. If abnormal, then it is to be replaced. Top up the gearbox oil, which is recommended by OEM up to desired level. Not to mix any other brand of oil with same grade, and use anti-foaming additive. If contamination is suspected, a sample of oil can be obtained in a glass jar, which is then allowed to sit overnight. When the jar is turned over, any contaminant will remain visible on the bottom surface of the jar. Water contamination in the lubricant can also be determined very quickly by placing a few drops of oil on a hot plate. If the oil drops crackle or sizzle, there is water present, probably in excess of 1000 ppm, that is 0.10%, which is detrimental to gear drives. In many cases, any water, if excessive, will separate from the oil sample in a jar stored overnight. If contamination by dirt, water, or wear metals appears to be excessive, laboratory oil analysis should be carried out immediately. Breathers are an important component of any gearbox. They allow heat to escape and cooling air to enter the system, preventing unnecessary overheating issues. A plugged or restricted breather will cause excessive housing pressures to develop, which in turn may cause seal leakage. Breather caps usually contain wire gauge filters that are intended to restrict the ingestion of dirt and dust. These filters are useless and should be replaced with good quality filters with absolute ratings of at least 5 microns to prevent airborne particulate from entering the gear housing. Hope so you have achieved something from my session. So please like, share and subscribe if you like my session. Thank you.